Hello, people on the internet. We're going to answer the question, how do we evaluate trig functions for any angle? And in this video, we'll cover evaluating from a given point, evaluating trig functions of quadrantal angles, reference angles, and how we use one trig value to find all the others. Let's get going. All right, the first thing that we're going to talk about is evaluating trig functions from a given point x and y. And see, we can use the distance out x and up y to find the hypotenuse of this triangle, since this is a right triangle. And we can use that to evaluate all the trig functions. From SOHCAHTOA, we can build all of our just basic trig functions in terms of x, y, and r. And r will always be positive. So here, let 8, -6 be a point on the terminal side of an angle. Find the 6 trig values. All right, the first thing that we want to do is figure out where the point 8, -6 is, right? And that's going to be in this fourth quadrant. We're going to go out 8, down 6. And from this, we can draw this angle. So let's build the triangle and label the sides. Once you have the triangle, you're going to want to use Pythagorean theorem to find r. In this case, r is equal to 10. And remember that even though it's here in the fourth quadrant, r is always positive. And we always want to use this angle that's here at the origin as our theta. From this, we can build the 6 trig values. Now, whenever you're filling out these trig values, you want to remember to reduce. So like the sine of theta would be -6 over 10. So we can write that is -3 over 5. And so after that, you can just go through and fill out all the trig values based on that angle. All right, and that's how we find all the trig values when given a specific point. All right, so the common quadrantal angles. All these are whenever the angles hit one of the axes. So the most basic is an angle that's not even open, right? It's just sitting on the x-axis. We have 0 degrees or 0 radians. And although this angle continues on, or this ray, we can pick a point and we'll call this R0. Which should make sense because, you know, you've gone some distance out R and haven't gone up at all, so 0. So going through these, the next one, this would be at 0r, and the theta would be at 90 degrees or pi over 2 radians. Finally, with these last two hitting this axis over here, we have theta equal to 180 degrees or pi radians, or here 270 degrees or 3 pi over 2 radians. Now what's really going to help us is that in most cases we can set r equal to 1, and that'll just make the math a lot easier. Alright, so let me show you how this works. So if you were to take the sine of -180 degrees, that is this angle right here going -180. So I pick this r on the terminal side and I just set r equal to 1, so this would be at -1, 0. And since sine is just y over r, I can say, okay, the y was 0 and the r was 1, so the sine of -180 is 0. Now you take a second and try the tan of 3 pi over 2. Alright, well if you got this far, you saw that you're at the point 0, -1, here's the angle 3 pi over 2, but you may have run into a problem whenever you see that the tan of this theta is equal to y over x. And a quick note, I should have said sine of theta over here. And but y over x would be -1 over 0, which is undefined. And that's the trig from quadrantal angles. All right, next up are reference angles. These are the closest angles between the x-axis and the terminal side of an angle. And a lot of times we write it as theta prime. And our reference angles will always be positive. So basically, if you had an angle like this, where the theta is sweeping around, the reference angle would be this angle right here, because it's the closest angle between the terminal side and the x-axis. And because we're always going back to the x-axis, it's useful to remember that on this side, this is either pi radians or 180 degrees, or on this side, it's 0, 360 degrees, or it's 2 pi radians. All right, so let's do an example. Let's sketch and find the reference angles. On the first one, we have 300 degrees, so let's sketch that angle. All right, so here that angle is, it's 300 degrees. Now, in our heads, we need to be thinking, well, if we went all the way around, this would be 360 degrees. So what angle do I need to get back to that x-axis? Well, that would just be another 30 degrees. So my reference angle is 30 degrees. This can be a little bit more confusing whenever you're doing radians, but as long as you list out the values of the x-axis with a common denominator, like 3 here, it makes it a lot easier. All right, so here I have my axes. Now I'm going to be doing a negative angle, so pi is also negative pi. Now if I want to make a common denominator so I can see this easier, that'd be negative 3 pi over 3. That helps me see that negative 2 pi over 3 is a little bit less than that. This is the angle negative 2 pi over 3. Now how much do I need to get from negative 2 pi over 3 to negative 3 pi over 3? I just need one more pi over 3. And if you're thinking, well, why is this one positive? Because our reference angles are always positive. All right, and that's how we find reference angles. All right, in these last two examples, we're going to use one trig value to find others. And to do this, we're going to have to remember our rules. You know, the sign is like y over r and such, and that r is greater than 0. So, look, let tan equal 5 over 12, and the sine of theta is less than 0. Well, remember, so I look over here. If the sine of theta is less than 0, then the y must be negative since r is always positive. So basically, any time that you see the sine is less than 0, then you know that you have a negative y. So now whenever we go to draw this, we have to figure out what quadrant are we in. Just because the y is negative, that tells me it's either quadrant 3 or 4. And to decide, I look, okay, the tangent's positive. So I go over here, tangent is y over x. If this is negative, if the y is negative, then the x must also be negative to give me a positive tangent. So this tangent of 5 over 12 actually came from negative 5 over negative 12. And again, this is just y over x. So let's draw that point here in this quadrant. All right, so now we basically can do what we did earlier, just doing trig from given a point. I'm going to use Pythagorean theorem and then find all the trig values. Pythagorean theorem tells me that this must be equal to 13, so now just using y over r, x over all this stuff, I can fill out all the trig values. And as I fill them out, I just quickly check myself. Is the sine of theta less than 0? Yes, it is. All right, let's look at one last example. Here we see that the secant of theta is negative 3, the cosine is negative, and the sine is positive. So basically, the x is negative and the y is positive. That puts me in quadrant 2. So as I'm trying to find this point, I remember that secant of theta is equal to r over x. And since r is always positive, that would be square root of 3 over negative 1. So we have a hypotenuse, square root of 3, and this x value is negative 1. Use Pythagorean theorem to find the y value to get your point. And there we have, it's this positive square root of 2. Now we need to fill out all of these, and remember that you have to rationalize denominators. And what I mean by that is, like, look at sine of theta. You have square root of 2 over square root of 3. Well, you can't leave a square root of 3 in the denominator. So you multiply by square root of 3 over square root of 3 to get the square root of 6 over 3. Now fill out the rest of them. All right, after filling out the rest and then rationalizing denominators, these are the answers that we come up with. All right, so that's everything for this video. We've figured out how to find trig values for any angle. Goodbye.